Hi, my name is Jaleny F, and what we're working with today is lesson 12.5 in the geometry textbooks. This is regarding circles and coordinate planes. The first thing I'm going to introduce is theorem 12-6, and that's the equation of a circle. So that states that the equation of a circle with center HK and radius R. By proving this, you first introduce the distance formula, and then you substitute, and then you move on from there to figure out how and why this works. So the first thing I did was utilize the distance formula, which is d equals the square root of parentheses x2 minus x1 parentheses squared, and plus y2 minus y1 squared. Then we substituted x2, y2 to x and y, and x1, y1 to h and k, which left us to the final product of r equals the square root of x minus h squared plus y minus k squared. From there, we can get to the third step, which is squaring both sides so that the square root comes across an inverse operation and it is no longer there, it's canceled out. However, the r, the radius, also becomes squared. So now the equation turned into r squared equals parentheses x minus h squared plus parentheses y minus k squared. So that is how you prove theorem 12-6, equations of a circle. So for this first example, we're going to find the standard equation of the circle with center 2, 5 and radius of 7. The first thing we're going to do is we're going to take the standard equation and we're going to substitute 2, 5 into it, as well as a radius of 7. So that would lead you to 7 squared equals parentheses x minus 2 parentheses squared plus parentheses y minus 5 parentheses 2. And once you simplify that, you're going to take the 7 squared and change it to 49. So it would be the same exact equation over here from over here, except the change in the radius, because it's simplified. So now that we have that packed down, we can move on to examples. And this example states, find the standard equation of a circle with center 8, 2 and the radius of 9. So the first thing you would do is you would refer back to theorem 12-6, equations of a circle, and get this equation. And afterwards, you would substitute the center, HK, into the equation, which would leave you to 9 squared equals parentheses x minus 8 parentheses squared plus parentheses y minus 2 parentheses squared. And the radius of 9 eventually follows into the r variable, so it's right there. And then we simplify. So 9 squared would be 81, obviously, equals parentheses x minus 8 squared plus parentheses y minus 2 squared. And this is the final product. So this is another example, quite different than the last ones. And this asks what the standard form of the equation of the circle for a circle with the center -3, 3, that passes through the point 4, 0. So the first thing to do in this type of equation and question example is to utilize the distance formula to find the radius first. And what we're going to do is we're going to substitute the d that was supposed to be in the distance formula for the r. And from there, you can substitute hk, which is the center of the circle, -3, 3, to x2 and y2 regarding the distance formula. So then that would create a formula of r equals square root of parentheses -3 minus 4 squared plus parentheses 3 minus 0 parentheses squared. And the point that the circle passes through is supposed to be substituted from xy to x1, y1. And once we get from here, we can simplify that into this second to last product, which is r equals 49 plus 9, and then we can add 49 and 9 and get 58. That's our final product for the radius. And we're going to utilize the radius to find the standard form. Now that we have the radius from the last step, we can utilize this to introduce us into the next step. This one utilizes the standard form, and we're going to substitute hk, negative 3, 3, into this equation as well as the radius we got. And so that would eventually lead up to the final product of brackets x minus parentheses negative 3, parentheses, brackets squared, plus brackets y minus negative 3, brackets squared, equaling 58.
Look up what's the average question about the Pythagorean theorem. The average Pythagorean theorem question.
Not even.
Hello.
Boom! Boom! Boom!
Habibti.